Here we're going to look at topic 87, example 1, add rational expressions with like denominators. So the concept we're looking at here is the same as if we had fractions like this, where you have a common denominator. So the denominator here would be 2 and 2. So what we can do, since they have a common denominator, we can add up the numerators, and then if you could simplify, you could. But the idea is we're going to start with like denominators. We're just going to use rational expressions. Okay, so let's get into the example A. So example A, if I look at the denominators are the same. So I then can just combine these fractions or rational expressions. My numerator would be x plus 5. And that's it. I cannot cancel these out. The x's, remember, we cannot divide these. Right? The x plus 5 is a group, wrong color. The x plus 5 is a group. The x plus 4 is a group. And if you're going to cancel out, say, the x, you also need to cancel out the 5, which we cannot do in this case. So this would be our solution, we'll say. We do need to look at the domain. So our domain would be all real numbers, except, and then my denominator, which is the same from the original fractions, the original rational expressions, x cannot be equal to -4. So the domain, all real numbers except x is -4. All right, part B, we're going to be looking at the same thing. Notice that your denominators do appear to be different, but if I was to factor my first rational expression, so if I take this 2x plus 1, and I look at the x squared plus 3x, they have a common factor of x. So if I factor out that x, I am left with x plus 3. And now my denominators are the same. So I'm going to add this second rational expression. The denominators are the same. So what we can do is we can do 2x plus 1. I'm going to write it all together as one group. You wouldn't have to show every single one of these steps as you get better at this. The parentheses are not going to make a difference here. So we have 2x plus 1 plus 3x minus 8. I would then look to combine any like terms in the numerator. So we get 5x minus 7 over x times x plus 3. You should check at the end to make sure that you cannot factor the numerator or the denominator, which is already factored. But the numerator, there's the chance that you'll have to factor again, and then you'll have to reduce or simplify, which you'll see, I believe, in example 3. We'll get to that when we get there. But just check to make sure you cannot factor the numerator, which in this case, 5x and 7 have nothing in common. So that fraction, rational expression, will be left alone. We do want to look at our domain. So our domain, again, is all real numbers, except, now, if I look at this x here, x cannot be equal to 0. So that 0 comes from there. And then this piece here tells me that x would not be allowed to be -3. Notice that the denominator is pretty much the same the whole way through. You should always look at the factored forms and your final answer to see if there's any extra exceptions that you have to look at. But as you go through this process, the two things you should be looking at very, very frequently are whether anything can be factored and whether there's been any additions to my domain or any extra exceptions. But adding rational expressions with like denominators is pretty simple. The denominators are already set up for us, so we don't have to do a lot of work there. We just have to make sure that we combine our numerators appropriately and that we check our domain and make sure we list our exceptions. That's it for example 1.